Hello and welcome to the solar design tutorial here. This is a website for some software that's very helpful. This is their website, some contact information. Let's go into their calculator here. We can use this for a starting basis for a system. Let's call it a 54,000 watt or 54 kilowatt system that we're going to design towards. Here we select a module manufacturer and a module part number. The electrical specification should drop down below that, so that's all automated. Let's check that against the cut sheet from the manufacturer. Here's our part number, and here's all the specs. Okay, so those should match. Let's go back to the calculator now that we've checked that. And next is inverter. So here we'll do the same thing again. We will select a manufacturer, and then we will select a part number for the inverter that we would like to use. And the same thing will happen below. We'll get the electrical specifications that we need. Okay, we will also check that to the spec sheet. So here, let's do the same thing. Let's use a PV-powered 50 kilowatt inverter. There's mechanical specs, electrical specs, so we want to make sure that all checks out for our job site. Okay, let's go back to the calculator once we've checked that. Okay, so now we're going to get into temperature. So there's a few ways we could do this. I'm going to go ahead and use drop downs to select a nearby location. There's other ways to go about doing that as well. There's a little button there that offers a different way to do it through their website. Okay, so all the weather information drop down below there. So based off those parameters that we have so far, module, the inverter, temperature, this will help us calculate our strings, both the size of the strings of modules connected in series and the number of parallel inputs that we can have to the inverter. So you can see there it turns red when your inputs that you enter in are not within the allowable parameters. Those parameters are shown just above there. So when you're within the tolerable range, everything should stay in blue. Okay, so the yellow has a problem, red has a problem, so let's set those back where we need them. Okay, and right below there you can see the voltage that we need to stay under, and the calculator does all these calculations for you, so that's good. We can pull up another little calculator here to see if we're hitting our system size, and we are. So the stringing looks good. So the next thing down here is our combiner box configuration tool. So based on the strings, we can select an ampacity. Tells us how many combiner boxes we'll need to use that ampacity. Let's try and keep as few combiner boxes as possible. In this case, that's going to be one. So it looks like we have 200 amp combiner box. We can get away with using one of those. That's probably going to be best for this system, since we won't be using a integrated combiner box in the inverter. We'll have an external one. And so we jump over here to the next tab, which is the equipment schedule. So as we look at that, so we'll select our combiner, and then the inverter is not going to be a 2-circuit, but we'll change that later. Let's go to the next tab, that's the conduit schedule. Okay, so this conduit schedule will take all of the inputs from our next 40 calculation tabs. You can see those named below individually as C1, C2, etc. So those will automatically be input here, and then we'll be able to change the conduits. So let's go into the first calculation tab. So we're there. So we're looking at our D rate. Okay, conductor rating. Let's leave that 75C. Material. Let's leave that aluminum for the conductor. This is single phase, since our first conductors that we're going to be calculating are DC. The temperature, let's pull that from the temperatures back here. So that's 38 degrees Celsius, and below that it does a little calculation showing you what it is in Fahrenheit as well. Okay, so let's get into our inputs. Okay, 592 for the design voltage. We're pulling these all from the first sheet here. Okay, module parameters, that'll have our voltage there that we can calculate out. So we have the correct inputs. Let's go back to the calculation tab. So there's our operating voltage. That'll be for voltage drop. Design current now. So that'll be for our overcurrent protection and what we're designing the conductors for. Okay. Let's check our math. Okay. Okay, let's enter that into the calculator. So there's the reminder text in red for the calculation and the D rates that need to be applied there. We will put that under design current. And then for operating current, we will check that now. And we'll do that calculation, put that number in the appropriate box under operating current. Now let's make up the length here. Use a round number, 100 feet. Okay, so we see this gives us a minimum conductor size, and then we made our conductor size in blue match, and based on that we can see what our voltage drop is at 0.25%. That should be acceptable, so let's keep that. We won't upsize the wire above 350. Then it automatically populates into the conduit schedule. So let's go ahead and go to C2 now, which will be on line 2 of the conduit schedule. Okay, still DC, still aluminum, single phase. Okay, 38 again. Voltage. Still that from the last sheet, since we're still on the DC side, it should remain the same. So this is another way of doing it here. This tab is set up to where you go through and you calculate your design current, and then when you're finished with that, we'll overwrite those fields with our voltage drop calculations. So we can name our conduit schedule however we like. Let's do that. Then we get to the drop downs. Okay, we see the wire size matches. Okay, let's go into an AC calculation now. So 1.25 is our new factor. It's three-phase based on the inverter that we're using. We keep aluminum conductors. Okay, so we get our current from there. Design current, voltage drop current are both operating, so those will be the same field. There's no need for two separate fields there. Okay, so there's our design current. Call this 10 feet. So we should have pretty low voltage drops. Going with the number 2 should be fine for voltage drop. And yeah, it's under 0.1%, so that is acceptable. See what happens if we make it very long. Okay, now that's 5%, over 5%, that's not good. 1 aught makes that 3%, bump it up to 300, and we're just above 1%. That should be a good number to go with. Of course, you can do as much cost analysis as you need to confirm what that number should be. Okay, we'll make a new name for those. Whatever your typical nomenclature is fine. Okay. Where it's coming from, where it's going to. Typical conduit schedule. We can change the insulation rating of our conductors. And if we do that, that will change the fill percentage. So you can see we adjust until we have the right size conduit. So we can play with that. We can make it bigger and have more fill, or we can put it right there on the edge. We can change the max fill, so depending on whether it's a bend or whatnot, a nipple, we can change that maximum fill percentage there. So if it's too small, it'll tell us too small in the conduit fill percentage. So we don't want that. Too small. Okay, so we don't want that. So let's change it back from a 2-inch to 2.5 inch. Nope. Let's make it a 3-inch now. See, it's too small. Very easy. Okay, there we go. Play around with our insulations if we like. Okay, back to the equipment schedule. This is where we can run some of our automation into AutoCAD. Okay, so starting fresh here in AutoCAD. Okay, that's what happens when you hit the button to run the tool. You get all your thousands of coordinates. So we'll copy that to the clipboard. We don't need to save it, but we can. Okay, gives us a little bit of prompting here. And then AutoCAD with the add-in for AutoCAD. Once we run the AutoCAD add-in, we should be able to just hit Control V to paste it right in there. And then it's all automated. It allows us to paste that in. Oh, and a little bug there. Let's try that again. We forgot to do the conduit schedule first. Okay, so let's get the conduit schedule. All right, that's generated through Excel. Okay. So we can save that wherever we want it to go, and we will go back to our tool in AutoCAD, and we will browse for that file we just saved for the spreadsheet that was generated with our conduit schedule. So let's find that. I already know where it is. There it is, conduit schedule. Okay. Okay again. Okay, one more time. And it should populate here in just 1 second. There we go. Now this is its own separate spreadsheet. We can manipulate this however we need to. So we have our line drawing. Now this is very, very basic. We didn't go through all the calculation tabs, so we can clean this up a little bit in Excel, or we could just do it here in AutoCAD, either way. Okay, we don't need all this stuff. But we might in other projects, so that could be potentially filled out more. But I didn't want to go through a whole entire workup for this presentation. Okay, let's just move this on down. Right there. Okay, let's take a look at our spreadsheet here a little more closely. So, it's not formatted in a way that is really good for us right now, but we can format it however we like, really easily within AutoCAD. So we can drag individual rows, individual columns. We can shrink or enlarge the entire thing. We can delete rows or cells as needed. So let's go back to that file we generated, and we'll just delete all that stuff we're not using. Bam. Okay, let's clean it up. Alright, so let's save again. Just do a quick save. Okay, back to AutoCAD, and we will update the definition. Boom. So you can adjust this to your template and your style however you need to. Manufacturer of this software does allow for customization. You can actually come in and do some consulting, customize this for you. So it'll work with your design team, with your business style. And with your templates that you already have, of course. So there we go. Thank you very much.